Hello, everyone. It's a pleasure for our company to present our latest solution to you. Today, I will introduce Bluetooth BR EDR host layer. Today's introduction mainly includes the following topics: device management, service discovery, and link management. Firstly, let's talk about device management. Including Bluetooth device address, BR EDR device name, BR EDR class of device, BR EDR device mode, BR EDR device discovery, BR EDR security management, and BR EDR device initialization. Each Bluetooth device shall be allocated a unique 48-bit Bluetooth device address. The address shall be a 48-bit extended unique identifier created in accordance with Section 8.2 Universal Addresses of the IEEE 802/2014 standard. The Bluetooth device address may take any values except those that would have any of the 64 reserved LAP values for general and dedicated inquiries. The reserved LAP addresses are 0x9E8B00 to 0x9E8B3F. The general inquiry LAP is 0x9E8B33. All addresses have the least significant bit at the rightmost position, hexadecimal notation. The user can configure Bluetooth device addresses through the System Configuration page in MCU Config tool. The user shall call the API GAP set BD address API to set Bluetooth device address after BR EDR host initialization. The BR EDR device name is the user-friendly name that a Bluetooth device exposes to remote devices. The user can configure BR EDR device name through the General page in MCU Config tool. The user shall call the API BT local name set API to set local BR EDR host device name after BR EDR host initialization. Class of device is used to indicate the type of device. The class of device is composed of 4 fields: a major service classes bit field, a major device class enumerated value, the minor device classes, and a fixed value of 0B00 in the 2 least significant bits. The class of device is defined in Bluetooth document. The user shall configure class of device before BR EDR host initialization. There are 4 device modes. The user can change the connectivity and discoverability of the device by configuring device mode. The default BR EDR device mode is idle mode, which means undiscoverable and non-connectable. The discoverable mode parameters include inquiry scan type, inquiry scan interval, inquiry scan window. The connectable mode parameters include page scan type, page scan interval, page scan window, page scan repetition mode. The user shall configure default parameters before BR EDR host initialization. After BR EDR host initialization, the user can call BT device mode set API to set BR EDR device mode. The purpose of the BR EDR inquiry procedure is to find the discoverable BR EDR device nearby. The user can call BT inquiry start API to start an one-time inquiry procedure. After one-time inquiry started successfully, the application will receive a BT event inquiry result event when a nearby device is found. The application will receive BT event inquiry CMPL event after one-time inquiry command finished. The user can call BT periodic inquiry start API to start periodic inquiry. After periodic inquiry started successfully, the application will receive a BT event inquiry result event when a nearby device is found. The application will receive BT event inquiry CMPL event after once inquiry procedure finished. The periodic inquiry won't stop automatically, and the user can call BT periodic inquiry stop API to stop periodic inquiry. BR EDR security management will be introduced with the following 5 parts: pairing mode, authentication requirements, I/O capabilities, OOB data, BR EDR bond information management. The pairing mode parameter is used to configure whether pairing with a new device is allowed. The authentication requirements are used to configure MITM and bonding flags. The I/O capabilities are used to set local input and output capabilities for device authentication. The I/O capabilities should be set properly according to the device hardware. The authentication method during pairing is determined jointly by the input and output capabilities of both devices. The mapping between the device's input and output capabilities and the authentication method is as shown in the table. The OOB association model is primarily designed for scenarios where an out-of-band mechanism is used to both discover the devices as well as to exchange or transfer cryptographic numbers used in the pairing process. The structure of the OOB data is shown in the diagram. The mandatory parts include length and address, while the optional parts include device type, simple pairing #C, simple pairing randomizer R, and local device name, among others. The OOB mechanism may be implemented as either read-only or read-write. If one side is read-only, a one-way authentication is performed. If both sides are read-write, a two-way authentication is performed. Each OOB transfer will have unique C and R values. After each OOB transfer, the application shall obtain a new set of values for the next OOB transfer. If gap auth and bit bonding flag has been set in authentication requirements, the application should manage the bond information of paired devices. The application can manage bond information using the implementation in the BR EDR host. The maximum bond device number means the maximum bonded device number. The contents of bond information in BR EDR host for each bonded device are bond information index, bond information priority, remote Bluetooth device address, link key type, link key, and bond flag. BR EDR device initialization, including two parts, BR EDR device parameters initialization. The user should call gap BR set perm API set BR EDR device parameters. And before starting BR EDR host, the user should also call BT Manager QFAC Register API to register callback functions for receiving events reported by the BR EDR host. The user can call gap Start BT Stack API to start BR EDR host. Now let's talk about service discovery. Service discovery will be introduced in three parts: BR EDR SDP capacity, BR EDR SDP data representation, BR EDR SDP initialization. The service discovery mechanism provides the means for client applications to discover the existence of services provided by server applications as well as the attributes of those services. The attributes of a service include the type or class of service offered and the mechanism or protocol information needed to utilize the service. The server maintains a SDP database which consists of a list of service records that describe the characteristics of services associated with the server. Each service record contains information about a single service. A client can retrieve information from a service record maintained by the SDP server by issuing a SDP request. Device ID information for the device is exported in terms of an explicit SDP record on that device. The device ID service record attributes including specification ID, vendor ID, product ID, version, primary record, and vendor ID source. As shown in the figure, the application can call BT did discover start API to start a did discover procedure. The application will receive the BT event did attr info event with did attributes information. After the did procedure is complete, the application will receive the BT event SDP discover CMPL event. As shown in the figure, the application can call BT SDP discover start API to start a profile service discovery procedure. The application will receive BT event SDP attr info event with profile service attributes information. After the discovery procedure is complete, the application will receive BT event SDP discover CMPL event. all of the information about a service that is maintained by a SDP server is contained within a single service record. As shown in the figure, the service record shall only be a list of service attributes. The service attribute consists of two components, an attribute ID and an attribute value. An attribute ID is a 16 bits unsigned integer that distinguishes each service attribute from other service attributes within a service record. An attribute ID is represented as a data element. The attribute value is a variable length field whose meaning is determined by the attribute ID associated with it and by the service class of the service record in which the attribute is contained. An attribute value is represented as a data element. A data element is a typed data representation. It consists of two fields, a header field and a data field. The header field, in turn, is composed of two parts, a type descriptor and a size descriptor. The data is a sequence of bytes whose length is specified in the size descriptor and whose meaning is specified by the type descriptor. A data element type is represented as a 5 bits type descriptor. The type descriptor is contained in the most significant 5 bits of the first byte of the data element header. As shown in the table, describes the definitions of data element type descriptors. The data element size descriptor is represented as a 3-bit size index followed by 0, 8, 16, or 32 bits. The size index is contained in the least significant 3 bits of the first byte of the data element header. As shown in the table, the encoding method for the size index is illustrated. The SDP table will be initialized after the application calls BT Manager init API, and the application should add or delete SDP record after this step. The application can call BT SDP record add API to add SDP record so that the remote device can find this service through the SDP search process. Now let's talk about link management. The BR/EDR link management will be introduced according to the following two parts: BR/EDR link establishment, BR/EDR link control. The purpose of the link establishment procedure is to establish a logical transport of ACL type between two Bluetooth devices. As shown in the figure, the application can create an ACL link by initiating a SDP discovery process. And BR/EDR host will check whether ACL link existed. If not, link creation process initiated automatically. After the ACL is established, the application will receive BT event ACL con success event. And then after BR/EDR host sets default link parameters, the application receives the BT event ACL con ready event, which means link ready. If ACL link created failed, the application will receive BT event ACL con fail event and BT event SDP discov CMPL event. The application can initiate a BR/EDR profile connection process after link ready. The BR/EDR host layer will check profile security and trigger authentication and encryption process automatically. The pairing process will be triggered if the application has no link key. The two figures illustrates the authentication and encryption processes for applications with and without a link key. BR/EDR link control will be introduced in 4 parts: BR/EDR link role switch, BR/EDR link QoS configuration, BR/EDR packet type configuration and BR/EDR link sniff mode configuration. As shown in the figure, the user can trigger role switch process after link ready. If the role switch process succeeds, the application will receive BT event ACL role master or BT event ACL role slave event. If the role switch process failed, the application will receive BT event ACL role switch fail event. As shown in the figure, the user can call BT link QoS set API to configure link QoS. If the QoS configuration process succeeds, the application will receive BT event link QoS set CMPL event. Otherwise, the application will receive BT event link QoS set RSP event. As shown in the figure, the application can configure using specific packet types for link communication. If sniff mode is enabled, the Bluetooth Manager module can automatically enter or exit sniff mode in different scenarios. The user can call BT Sniff Mode Enable API to enable BR EDR link sniff mode or change sniff mode parameters. And the user can call BT Sniff Mode Disable API to disable BR EDR link sniff mode. Thank you.